Welcome to lesson 2, which is about sum of the angles in a polygon. So before we look at the sum of the angles in a polygon, we have to understand what a polygon is. And basically, it is a shape that is made up with given number of sides. If we look at regular polygons, okay, this is what happens when all of the sides are equal. And a lot of times you will see this indicated by little dashes on each of the sides, meaning that these are all equal to each other in that polygon. And it can be anything from a triangle to an octagon, and of course there's many other examples. All of these are also examples of convex polygons. And what that means is that you have a polygon where all the interior angles are less than 90 degrees. So if you look at all of these angles in here, they are less than, not 90, sorry, 180. These are less than 180 degrees. So every single angle inside is less than 180. So then we have our convex polygon. We can also have things that are called concave polygons, and I'll just move this up a little bit so we can keep everything on the same page. We have concave polygons, and concave polygons will have an angle that is more than 180 degrees. So if we look at this, this is less than 180, less than 180, less than 180, less than 180 down here, less than 180 here. However, this angle on the inside is more than 180 degrees. Okay, so to be 180, this is 180 right here, and then it's beyond that. Okay, so that's your concave polygon. Now, the problem that we need to figure out is to determine the missing angle for this convex polygon. We want to find out what the measurement of that angle is. So what we need to know is the relationship between the number of sides of a convex polygon and the sum of the interior angles. Now this one that we have right here has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 sides. But as you can see, all of the angles are very different. So we need to find out what the relationship is between the number of sides and the sum of all of these angles, so we can find the answer to this one right here. So that's what we're going to do next. Now, if I were there, of course, we would do a little investigation and I would have you measure some of these things, but we don't. So if we measure the angles of polygons and we collect the data, you would actually see that the numbers would look something like this. If you have a triangle, 3 sides, the sum of the interior angles would be 180. 4 sides, they would be 360. 5 sides, 540. 6 sides, 720. 7 sides would add up to be 900. And 8 sides would add up to be 1080. And that's something that we can investigate together later on next week. What I do want to look at, if you think back to the other units that we've been doing, our x, or let's call it our n for number of sides, is going up by 1s. And our y, or sum of the interior angles, okay, how much is this going up by? Well, if you do the math, 180, 180, 180. So don't forget all the other stuff that we've learned. The first difference here is 180. So that means our slope is 180. Now that we have that important piece of information, we can go back and look at how this kind of relates to what we need to know. So we know that this is a linear relation because as the x is going up by 1, the sum of the interior angles is going up by 180. So you have that constant rate of change. That means it's a linear relationship. Okay? Remember our linear relationships, we indicate that by y equals mx plus b. M is our slope, b is our y-intercept. Okay, so let's just substitute in our variables that we were using. And remember we said we wanted to call, and I'll just go back for a second. We said our number of sides, our x value, I called it n for number. Our y value, I called it Sn for sum of interior. So for our y, we put in the sum of the interior, Sn, and we're going to put n in for our x value for the number of sides. Once we have that done, we can substitute any value from the table into the equation. So whatever value for n we have, we can substitute Sn. Now, let's just pick the smallest numbers to deal with because it's easier, and let's substitute this in. Don't forget though, what did we say our slope was? When we calculated the first differences, we said our slope was 180. Okay, so it's going to look something like this. Our slope is 180, and we calculated that as our first differences. We're plugging in 3 for our x value, and we're going to plug in 180 for our y value. When we do that, and we complete the calculations, 180 times 3 is 540. We have 180 on this side. We're going to bring the 540 over here, change the sign to subtract. So we have negative 360 equals b. What that gives us is now an equation that we can use for the sum of the interior angles. So no matter what, you can always, if you have so many sides, you can figure out what the sum of the interior angles is going to be. Or vice versa, if you have the sum of the interior angles, you can then solve to find out how many sides your polygon has. So let's go back to our original question. Determine the missing angle in the convex polygon. So now that we have this formula that we can use, sum of the interior angles equals 180 times n minus 360. We counted them up and we said we have 10 sides. So we put in 10 for our number of sides. And when you do the calculations, it comes out to be 1,440 degrees. That's the sum of the interior angles. Now that's the sum of all the interior angles, but we want to solve for x. So this is angle 1 plus angle 2 plus angle 3 and so on. If you add all of those up plus angle x, that's what we're looking for. So basically we need to take the sum of all of them, subtract all the others, and when you add that up it comes 1283, 1283. So this is the sum of all given angles. Okay, that's going to equal your x value. So when we solve, x ends up being 157 degrees. And if you don't believe me, you can add them all up on your own time and verify that that's true. On to another question. A regular polygon, we said, is a polygon where all the sides are equal and all angles are equal. So if you have an equilateral triangle, that is a regular polygon. All sides are equal, all angles are 60 degrees, because remember, they all have to add up to 180. 60 plus 60 plus 60 equals 180. A square is a regular quadrilateral as well, and all sides are equal, all angles are 90 degrees. But what if we have something that's this shape? Okay, we know that, going back to our formula, sum of all angles, okay, is 180 n, which is the number of sides, minus 360. Now we know how many sides we have. We have 1, 2, 3, 4, 5, 6. So the sum of all the angles is 180 times 6 minus 360. If you do the calculations for that, you end up with the sum of all angles are 720. And the sum of all angles, in this case, all of our angles are equal. So if all of these angles are equal, then all we need to do is divide that by how many angles we have. So our angles, our x, is going to be 120 degrees each. I can show you a little bit differently by doing it this way as well. We know that we have 6 times x. That's going to be the sum of our angles. And just by doing regular algebra, which is what we've been doing all along, x equals 720 divided by 6, which is 120. Now, just in case you don't believe what I've been saying, the relationship between the sum of the interior angles and the number of sides of the convex polygon is often explained by dividing the polygon into a number of triangles. And for some reason, we all tend to believe that in a triangle, all the angles add up to 180 degrees. So if we take that, okay, we can take any polygon. So let's look at the quadrilateral to start. Okay, if we take that quadrilateral and we divide it in two, and now we have created two triangles, one there and one here. And we know that if we have this triangle here, it's going to add up to 180, all of the angles, and all of the angles in this one is going to add up to 180. So if we have 4 sides, 180 times 2 gives us 360. If we take the pentagon, We have one triangle here. We have another triangle here. And we have another triangle here. The same thing goes to show we have 5 sides. We have 180. And we have 3 triangles. And that's 360 degrees. And the same goes. We have 1, 2, 3, 4. So now we are looking at a 6-sided figure. We have 180 degrees and we have 4 of those triangles equaling 180. And if you do the math, it's 720. Oh, I did make a mistake. It's not 360. Are correct? Take it easy. It is 540. Now, if we take this information, we can make a general formula, 180 times the number of sides minus 2. Sorry, I wrote that wrong. $180 times the number of sides minus 2, which would be 180n minus 360. And that takes us back to the original equation that we talked about at the beginning of this lesson. So that's just to explain to you visually how it makes sense and mathematically. Now I would like you to do this homework. You have questions in your workbook that you can work on. These instructions right here is for this diagram, and these instructions right here is for this diagram. Try those to start, and the supply teacher who's in for me today can just pause it right here for you so you can try these, and then, like I said, do the questions in your workbook. I think it's page 19, page 20, and the top of page 21. Once you're finished these 2 questions, please move ahead and try this question as well. So I will back up. Here you go. This doesn't want to work for me. I'll move this one up here, this one right here, and I will bring actually the other one forward to put them all on the same page so you can work with them. And it doesn't want to do that for me. So here we go. Oh. Let's group all that. And then let's copy it. And paste it into here. Oh. See, it's as if I'm there. It doesn't want to work. Okay, so here we go. I have fixed it for you. All three of these. So the first one, determine the values of x and y. And I don't know why that's happening. But determine the values of x and y using the parallel lines. The next question, determine all four angles in the diagram. And then the last one, the regular octagon, determine the value of x. Good luck, have a fantastic weekend, and I will see you on Monday.